Hello and welcome back. So, in this part of the session, we're going to go through our first hypothesis. So, for the very first step, make sure you have your kernel set. And if you haven't already, make sure it's set to the proper kernel. And then we're going to import some packages. And also, we're going to import the functions that we created of our own. So it's all under stat utils, and we have a lot of different functions that we can use. As an example, we have chi-square, ANOVA test, and for numerical tests, statistical test step 1. And this function will be the very most important function because it's going to do statistical tests on all of our columns. So if we set the analysis column, this will be a list of columns, and the target column, which from our point of view would be the fraud. And if we also provide the data set, then it will, and the back end, it will automatically determine the type of variable of this analysis column. So if it's a numerical one, it will conduct a numerical test. So inside this numerical test, we have different tests such as T statistics and KS tests. And if it's not a numerical type column, it's going to perform an ANOVA test. If the number of target variable is more than 2, it's going to perform a ANOVA test. And now if it's not a numerical type column, it's going to conduct a chi-square test. So we have a lot of tests prepared for our data set, and all you need to do is to provide the analysis columns and the target columns and the data set. Anyways, keeping that in mind, let's read our data set, and we're also going to split the individual columns according to its characteristics. So as mentioned before, the reason I do this is because it's much more easier to select the individual columns if I just group them according to their characteristics. So when performing some kind of a analysis or test, we sometimes want to look into all the columns that are related to certain characteristics. As an example, if we want to look into columns that are related to that specific person, we can look into the personal variables. And if we only want to choose the columns related to policies, we can use this kind of list. So if we look into the count plot of individual policies and their fraud, you can see that we have for non-fraud claims, we have collision, liability, and all perils. And when it comes to fraudulent claims, you can see that the number of claims related inside the liability column only has 36 different data points. So compared to 435 or 452, 36 is a pretty small number. So it's best to ignore this liability coverage because we don't have enough data points to do any statistical tests. So we're going to focus on collision and all perils. Now, for to make it easier for us, we're going to divide the data set according to its coverage. We're going to divide it into collision, liability, and all perils. So we're not going to use liability, so you can ignore this. And now, before going into the analysis, before going into setting our hypothesis, I mentioned that the second tip for you to follow is to cherry pick the starting point. So in order to cherry pick the starting point, you need some statistical grounds on how you chose those starting points. So if I just enable this again, and one of the method is to do statistical tests and find columns that are relevant to our target variable. So I mentioned this statistical test step 1 function, which is the very main and important function that I mentioned. And I'm going to use this. So I'm going to provide all perils coverage. So all perils coverage will have all the data set related to all perils. And the target variable that we want to set is the fraud column. And the other columns that we want to test against our fraud column is all the other columns that are related, all the other columns except the fraud. So here we get a list of all the relevant columns that are statistically significant and statistically has some kind of a relationship with the fraud when it comes to all perils. So we have accident area, month claim, age, fault, and etc. And we can do the same thing for collision too. So for collision, we have make, month claimed, sex, fault, policy type, vehicle category, vehicle price, and address change claim. While it's not meaningful, we can also do the same thing for liability. We have make and days policy claim. So ignoring liability, what we want to do is we want to select columns that happen both in all perils and collision. So in order to do that, we execute this code. And to walk you through this code, we are looping through all of the columns inside relevant columns in all perils. And we're only selecting the ones that are inside the relevant columns collision. So we're looping through all of these columns. And if any of these occur in this list, we are going to print it out. So we have month claimed, fault, vehicle price, and address change claim. And since month claimed is not that relevant, it only provides seasonality to the data set, we're going to exclude it. So that makes us with 3 different columns, and these 3 are the ones that we can select as a starting point. Now, in this part of the exercise, I'm going to provide you with a hypothesis that I already checked. So I used vehicle price against fraud found to come up with some kind of a hypothesis and also some insights. And the way I'm going to provide you with this is that I'm going to provide you with the conclusion first and then walk you through the overall process. For the second hypothesis, we can do it in reverse. We can first select some column and see how it performs against the fraud found, and then gradually come up with the insights. But for this exercise, I'm going to provide the conclusion first. So the hypothesis that we aim to look into is that insurance fraud is likely to be higher for expensive vehicles. So these vehicle price column will include all the price of the vehicles, and we want to see the relationship between the vehicle price and the fraud. So the business rationale most likely provided by the domain experts would look like this. The higher the vehicle price, the larger the insurance payouts. So it is more prone to be a target of insurance fraud. And specifically, this overall trend will be more clear in case of collisions because when it comes to higher priced vehicles, it's much more easier to create a false claim when it's a collision category. So based on this, the conclusion and application would be by using the above factors as criteria, insurance fraud detections can be improved, catching more fraudulent claims. So the objective of our analysis would be to come up with some kind of a insight so that we can provide this pattern to the domain experts, and the domain experts can incorporate these insights into their business flow. Now, as a very basic step, look into how vehicle price looks like. So this is a count plot, and we have 6 different categories. we have from 20,000 to 29,000, 30,000 to 39, more than 69,000, less than 20,000, 40 to 59,000, and 60 to 69,000. And a lot of vehicles are concentrated in more than 69 and between 2,000 and 3,000. Now, for all perils, if we look into these specific coverages, the overall pattern is pretty much similar, but you can see that the difference is that for all perils, the vehicles that are priced over 69,000 is on the second place rather than the third place. So this is something that we can focus on. And if we also look into the overall portion between fraudulent claims and non-fraudulent claims, we can get an overall sense of how and where and what we should be looking into. So if you look at the overall order of non-fraudulent claims and fraudulent claims, the overall order of these x-axis is pretty similar. The most cases occur between 20,000 and 29,000, and the second place is 30,000 to 39,000, and the same thing happens for fraudulent claims too. However, if you look into the portion of these categories, the overall portion of more than 69,000 is a little bit higher compared in when it's a fraud compared to when it's a non-fraudulent claim. So we have 686, 1,275 for non-fraudulent, and for fraudulent we have 100, and for more than 69,000 we have 83. So you can see that the gap between these two categories is much more smaller when it comes to fraudulent claims compared to when it's a non-fraudulent claim. So this is something that we could look into. And so to get a better sense of the overall portion, instead of this bar graph, we can use a heat map. So if we look into the collision category, you can see that the overall portion. However, right now there are just too many categories. It's a little bit hard for us to compare side by side because there are 6 categories, and it means that we have to compare them individually. And also, there are some categories that only have few data points, so we want to group them into higher groups so that it's easier for us to come up with insights. So here comes the third tip, which is making the analysis more digestible. So what I mean by that is we want to create another feature, but with a higher group. So if it's less than 20,000 and if it's between 20,000 to 29,000, we categorize it as less than 30,000. And if it's between 30,000 and 59,000, we categorize it as 30 to 59,000. And we also have another category which is over 60,000. So these will be the expensive cars, and these categories will belong to a cheaper model. Now, by creating this dictionary, we can map this dictionary to our vehicle price. So the new column that we have will be the vehicle price number. So we have more than 60,000, and if we just do unique, you can see that we end up with 3 different categories. And if we look into the value counts, you can see that the overall value counts is now much more better compared to having a few data points in each category.